Hi everyone, myself Tessin, and today I'll be presenting our Group 4 project on predicting the quality of water utilizing different ML models. And as part of this project, we have mostly utilized different machine learning technique to assess and predict the quality of water based on the various physical, chemical, and biological parameters. Let me start with the introduction and project overview. So, water quality monitoring is essential for safeguarding environmental health and public safety. Contaminated water can lead to severe health risk. So, as part of this project, the main aim is to predict the quality of water utilizing different ML techniques, focusing on identifying all the critical factors which can influence water quality. By leveraging data-driven models, we can provide proactive insights for environmental agencies and policymakers to ensure safe water resources. The objective is to build a predictive model that determine quality of water based on the multiple physical, chemical, and biological parameters. And this approach not only enhances monitoring efficiencies, but also supports proactive measures to prevent water contamination. Now coming to the goals and importance, the primary goal for this project is to develop a robust predictive system for determining water quality proactively. This involves analyzing a data set which is captured for various stations and then pre-process the data, do some cleaning just to make sure data is clean, and then utilize few of the machine learning algorithm to achieve high accuracy. And the importance of this work lies in its potential to automate water quality assessment, reduce manual testing cost, and provide early warnings for contamination. And by understanding which features most influence water quality, a stakeholder can prioritize interventions and improve resource allocation. Ultimately, this project contributes to sustainable water management, and we can also say like it is good for public health protection. Now, let me start with some insight on the data and what all exploration we have done with the data. So this is a data set which we have used. It contains data collected at various stations and collected for different parameters, which is being used as a feature for training the model and then utilizing it for predicting the quality of water, which is what we have used. And this is collected at each day level, and these are the values for each one of them. So yeah, let me go to the insights, like based on the data analysis, what all insight we have captured. So first thing is like we utilize data analysis using some feature distribution, and then detecting missing values, and then identifying outliers as well. Visualization techniques such as histogram and correlation heat maps were used to understand relationship between different features. For instance, high correlation were observed between nutrient levels and turbidity, and that indicates like these are the potential sources of contamination. Outlier detection using interquartile range helped identify extreme value that could impact model performance. These insights guided data processing decision and ensuring that dataset whatever we are going to use, it's clean and it's of decent quality for training the predictive model. Now coming to preparation and transformation. So like whatever few issues we saw with the data, how we have handled it. So first thing is like missing values. So we utilize median strategy to maintain data integrity to fill all the missing values. And for outliers, we address it using capping and in some scenario removal based on statistical thresholds to prevent distortion in model training. These steps ensure that dataset was complete and consistent, reducing the risk of inaccurate prediction caused by anomalies. Now coming to feature scaling and encoding. So for this, normalization was applied using a standard scaler, enabling the neural network to converge efficiently. Categorical variables such as stream condition were encoded using one hot encoding to convert them into machine readable format. Log transformation was applied to skewed feature uh, to stabilize variance and improve model performance. These transformations were critical for ensuring that all feature contributed effectively to predictive model. Now coming to the modeling approach, whatever we have used. So, several machine learning models were tested, including neural networks, MLP classifier, random forest, gradient boosting, support vector machines, and logistic regression. Now, this neural network architecture consisted of one hidden layer with 50 units optimized for classification task. Hyperparameter tuning was performed using grid search and cross-validation to achieve optimal performance. And the choice of multiple models allowed comparison of accuracy and robustness, ensuring the selection of best performing algorithm for deployment. Best performer, whatever we saw, it was based on the data set, whatever we have, and based on the testing result and validation result, it was random forest with 98% accuracy. Now coming to the results, what we have figured out after building the model. So this is a chart we have come up with confusion metrics which explain the result, predicts what model has predicted. So the neural network model achieved high accuracy and strong performance across precision, recall, and F1 score metrics. The confusion metrics reveal that most positive cases were correctly captured, though some misclassification occurred in minority class. This indicate that need for further optimization to handle or to improve the accuracy furthermore. Visualization such as the confusion matrix it may provide clear insight into the prediction strength and weakness. The model performed very well for class 1, which is to capture the good water quality with 867 correct prediction. However, class 0 where like class 0 for the poor water quality is harder for the model, and there are like 50 false positive. Poor water predicted as good is a critical issue because it could lead to unsafe water being considered safe. Now, there are 31 false negative, like it's like good water predicted as poor is less critical, but still this can be improved further to improve the overall accuracy. Now coming to the feature, so these are the feature like which is having very high in influence in predicting the quality of water. These findings align with environmental science principle explaining the role of nutrient level, water clarity, heavy metals, and bacterial contamination in determining water safety. And understanding these key drivers enable targeted intervention and resource allocation for water quality improvement. Now coming to the conclusion, what we have figured out. So this project successfully demonstrated the use of machine learning for water quality prediction, and key finding includes identification of critical features such as nutrient levels, turbidity, and heavy metals. The model predicted kind of model provided accurate prediction, though some improvement are needed for the minority scenario, but overall the accuracy is quite good. and these insights can guide environmental monitoring strategies and policy decisions. Thanks, everyone.